Hey everybody, Mr. Quick here. Welcome to Eureka Math / Engage New York Math, Module 4, Lesson 3, the relationship between multiplication and addition. Now, we have often heard that multiplication is just what? Repeated addition. I'll just put the plus sign there. And that is true. That's absolutely true. But being that there is that relationship that goes back and forth, there's a few rules that we can look at together to help better understand that relationship and how these two are connected. So let's go ahead and get started. Let's start with something really simple. I'll give you a couple of tape diagrams, or I'm going to give you one tape diagram here anyway, or one expression worth anyway. What you have here is three separate tape diagrams, and each are made up of equal sizes, right? So as we look at them, we have 1, 2, 3 sections here, so that's 3. 1, 2, 3 sections here, so that is 3 as well. And then 1, 2, 3 sections here, so that's 3. There's a couple of different ways you could write this. I'd like you to write an expression based on this. Pause the video, think about what it might be. If you don't pause it, you're just going to get the answer. There's no spoilers there or anything. But take a minute and think about two different ways you can write this. Unpause when you're ready. Okay, hopefully you've paused the video, thought about two different ways you could write this, an expression that represents this bad boy right here. And if you did, you may have come up with something like this. 3 plus 3 plus 3, right? Because we have 3 here, add another 3, add another 3. Okay? That's your equation. The other way you could write it is you could say, well, we have 3, and we have it 1, 2, 3 times, so we also have 3 times 3. And that's accurate. And these two expressions here are equivalent, because if you evaluated the expressions, this is 9, this is 9. So we're talking about the same thing. Two different ways of looking at the same thing. One with addition, one with multiplication. Okay, let's do an example here. Let's say you had two partners, and one wanted to build a tape diagram of the expression 3 times 4. The other wants to build a tape diagram showing 4 plus 4 plus 4. Are these equivalent? Are these the same thing? Well, if you do the 3 times 4, and you want to say we have 1, 2, 3, but we've also got to, so there's one set of 3, right? But we've got to build it 4 times. There's a second set of 3, 1, 2, 3. There's a third set of 3, 1, 2, 3. There's your fourth set of 3. We have 3, 3, 3, and 3. Over here, you may have a group of 4, plus a group of 4, and a group of 4. And what you end up with is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Both are equivalent. Now over here you could have also done 2, 3, 4. That's one set of 4. 1, 2, 3, 4. That's one set of 4. One set, and then 1, 2, 3, 4. That's another set of 4. Either way, you're looking at 4, and you're looking at it 1, 2, 3 times. Here you have 4, and you're looking at it 1, 2, 3 times. Or down here, we flipped it to 4 times 3. I mean, you can look at it either way, right? You have 3, 4 times. So, are these equivalent? They are indeed equivalent because they both are going to give you 12. Okay, let's look at some variables. If I gave you G plus G plus G, let's say this tape diagram represents, I shouldn't do capital there, represents G. Whatever that number is, we don't know what it is yet, but we're going to say that this size tape diagram is G. And I want to do G plus G plus G. Well, I've got to do 1G, another G of the same size, and another G of the same size. I could also represent that by what? Well, we have G, we have it 1, 2, 3 times, so we have 3 times G. When you use a variable, such as G in this case, even though it represents a number, we don't want to put 3 times G, because then it gets a little confusing. Is that multiplication, or is that an x. Is that like another variable? So we don't want to use that. So we just put 3g, and that is the same thing as 3 times g. All right? So essentially what I'm trying to get across here is that g plus g plus g is the same thing as 3 times g. And as we look at these kind of relationships, I want to show that you can write multiplication and addition, you can write multiplication as addition and vice versa. So let's look at a couple of examples here together. Okay, I'm going to give you an equation, and we're going to write the other version of it. Here we have 6 plus 6. That is 2 6s, so we end up with 2 times 6. Both are different ways of writing the same thing. 6 plus 6 is 12. 2 times 6 is 12. You can always check that by making sure that they equal the same thing. All right, here we have an expression 6 times 3. Well, another way we could look at that would be 3 plus 3 plus 3 plus 3 plus 3 plus 3. And I'm going to go back and count 1, 2, 3, 4, 5, 6, and make sure that I have 3 6 times. If you want to flip that, you could also write 6 plus 6 plus 6, right? So that's like 3 times 6, 6 times 3, same difference, right? You can flip them. Either way, you're going to get 18 here, you're going to get 18 here, you're going to get 18 here. 6 times 2. Well, again, 2 plus 2 plus 2. That's my third 2. There's my fourth 2. There's my fifth 2. There's my sixth 2. You could also say 6 plus 6, right? You can flip it because 6 times 2 is equal to 2 times 6. That goes both ways. What about, we have h plus h plus h plus h. I'm counting 4 h's, so that's the same as 4 times h. 4 multiplied by h. Same thing, right? Finally, we have 6y. 6 times y. So if we have y 6 times, we're going to have y plus y plus y plus y plus y plus y. And I'm going to go back and just double check that I have 6 of them, right? 1, 2, 3, 4, 5, 6. So 6y is the same as 6 plus 6, or excuse me, y plus y plus y plus y plus y plus y. It's just that relationship, multiplication as repeated addition. Okay, we'll look at some more examples of this in class. We'll talk more about it face-to-face. Thanks for watching. We'll talk to you later. Excuse the noise. I've got some painters out here painting my house, but I wanted to plow through and keep making the videos and not waste a day. So anyway, thank you for being patient with that, and we'll talk in class. Thanks.